between a sequential pattern mining and normal association rule mining. And the difference is that in the ARM, you do not consider the sequence of elements, whereas in the case of sequential pattern mining, the sequence of elements are important. It means that if A comes before B, therefore in that case, and B comes before A, these two are two different transactions, or we can say these two are two different sequences. And therefore, when we talk about these sequences, we have to make sure that whatever we are going to implement, the sequence must be maintained. Okay. Now try to understand this concept well, because this is tricky. Okay, now let me first of all discuss the terminology of sequence mining. Now, as told you before, that in a sequence mining, whenever you are going to take some transactions or items, the sequence has to be maintained like this. So let us try to understand this. Let sigma be the alphabet, that is a set of symbols, and a sequence or a string is defined as an ordered list of symbols and is written as S is equal to S1, S2 to Sk, where this value of this Si is an element of sigma. And when I say Si, it means that that symbol is at position number I. Okay. Now, whenever we are trying to implement such an algorithm, first of all, let us see how we are going to give the notations to this. Now, for example, I want to discuss, suppose the sequence I, J. Now, when this sequence will be taken, when I have the first one start with symbol Si and the last one becomes a symbol Sj, where in between there could be one or n number of characters or symbols. For example, Si, Si plus 1, Si plus 2, dot to Sj minus 1 to Sj. And then when I define this symbol, this is the substring or the sequence of symbols from position I to J, where J is always bigger than I. Why I mean to say J bigger than I? Because J comes after I. For example, if I take a symbol, say A, B, C, D, E. Now Si is A and Sj is E. And therefore, these sequences where J is bigger than I, because J is equal to 5 and I is equal to 1. Now, if I am going to define the prefix of the sequence S, for example, if I define the prefix of this prefix of this one will have start from say S1 to Si, such that I is always bigger than, greater than equal to 0, should be less than equal to n. That means this small s is a substring of the previous sequence. Now, if I want to discuss the suffix, that means it should come at the last. Now, the suffix will have the substring with the form of I to n, where it starts from I and ends to n. That means the prefix of a sequence S is any substring of the form S1 to I and any suffix of S is a substring from I to N. Okay. Now this is the important concept which you have to know, that how you are going to find the prefix of subsequence and similarly the suffix of subsequence. Now here S is a string which you are defining. Now here S is equal to S1, S2 dot 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 till K. That means there are K symbols in it. Okay. Now try to understand if any problem, which just please ask again. Now let us try to understand this, how we are going to calculate over this example. Now let S is equal to S1 dot dot to Sn and R is equal to R1 dot dot Rm with two subsequences over sigma. That means there are two sequences which are over the set of alphabets, which is sigma. Now we say that R is subsequence of S denoted by R is a subset of S. If there exists a one-to-one mapping, that is how we are going to find the one-to-one mapping between 1 to M and between 1 to N. We are going to, now you see M is a part of R and N is a part of S. Now here what I am trying to say is R is a subset of S. Therefore the mapping should be from each character of R should map with each character of S. Okay, and such that R of I is equal to S of phi of I for any two positions of I comma j in R. That means if such condition is satisfied, we say that I is subset of S, and we can also say S contains R. That means the whole of R is in S. Correct? Now, the sequence R is called consecutive subsequences or called a substr of S if R1 dot R2 dot dot till Rm is equal to Sj plus 1 dot dot to Sj plus M minus 1. That means those characters of R are matching in sequence in S, and therefore when I am going to do this, R1 to M is equal to S J to J plus M minus 1. Now why I am saying this? Because how many characters are between 1 to M? The M characters. How many characters are between J to J plus M minus 1? Obviously there are M characters. Okay. Now let us try to understand one example. Now let us see that I have only 4 symbols or alphabets which are a part of the sequences, and that they are A, C, G, T. Now this is equal to sigma. And let us take one sequence A, C, T, G, double A, C, G, which has been built over the sigma. Okay. Now, if I take, say, R1 is equal to CG double AG, CG double AG. Now, if you find over there, you find that that is a subsequence of S. Why? Because you find C is here, G double A is here, and G is over. Though it is not consecutive subsequence, but it is subsequence. Okay. Similarly, CTGA, CTGA are all consecutive. Therefore, this is a substring of S. Now try to understand the difference between substring and subsequence. In substring, it has to be continuous. Whereas in the subsequence, that sequence should be coming in S, which may not be in consecutive, but the order should be maintained. Okay, the order should be maintained. Okay. Now let us take this R3, which is equal to ACT. Now ACT is a prefix of S because that whole comes before at the starting of S. at the starting of that. Similarly, if I take ACTG, this is also a prefix of S. If I take ACTGA, this is also a prefix of S. And if I take, let us take, if I take CG, if I take just CG, this is a suffix of S. Similarly, if I take ACG, this is also a suffix of S. If I take this whole TAACG, this is also a suffix of S. That means for any sequence mining, it could be either a subsequence or a substring or a prefix or a suffix. Okay? That means it could be any one of them. But all of them are part of sequence. That means whether it is a subsequence or a substr or a prefix or a suffix, but they are all sequences because the order of characters are not changed and all the characters appears in the symbol, are a part of sigma and is a part of the string S. Correct? Okay, now let us try to come with the. Now, how will I find the frequent sequences? Now, you must remember the prior algorithm, and we are trying to apply the same type of algorithm over here. That means the prior algorithm will be applied similar to that algorithm only, will apply to find the frequent sequences. Now, suppose I have a database D which contains S1, S2, Sn, and there are n sequences. Now, this database D contains n number of sequences, and given some sequence R, the support of R in the database D is defined in the total number of sequences in D that contains R. That means if I want to find the support of some sequence, that is equal to that all the sequence must be a part of D, okay, and R must be subset of Si. That means R, which is the subsequence we are going to find, should be a part of all, be part of Si, where Si is equal to S1 dot S1 to Sn. Okay, that means when I find this here, Si, what I am going to find Si, this Si is nothing but S1 to Sn, and R is the sequence for which we want to find whether it is part of Si or not. Now the support of this is given by some number. Suppose it appears in 3 times, then the support of R is equal to 3. If suppose there are 10 sequences in the database and say R appears in 5 of them, then I can say the support of R is 5, and the relative support is given by support of R divided by n. Suppose it appears 5 times out of 10, we will say 5 by 10, that is 50%. And therefore, this is the frequent subsequences we want to find. We want to find whether any particular sequence R is frequent or not if it contains, if it is contained in million of that support threshold what we are giving. That means we will provide some specified minimum support, and we say that R is frequent in the database D if the support of R is bigger than minimum support. Okay. Now let us come to the thing what we have learned before, that is the maximum and the closed. A frequent sequence is maximal if it is not a subsequence of any other frequent sequence. Now you must be remembering the maximal frequent. A frequent sequence is maximal if it is not a subsequence of any frequent sequences, and a frequent sequence is closed if it is not a subsequence of any other frequent sequence with the same support. Now that definition might be applied for maximal mining, max mining, and close mining, we can apply the same definition in the case of frequent sequences also. That means a frequent sequence will be called a maximal if it is not a subsequence of any other frequent sequence. And a frequent sequence is closed if it is not a subsequence of any other frequent sequence with the same support. And you must remember that maximal is a subset of closed. Okay? It is a subset of closed. And max closed is a subset of frequent. Okay? Now let us see how we are going to apply the algorithm. Now, when we are going to apply this this algorithm, we will be we will generate a prefix search tree. The prefix search tree will start from the root, which is at level 0, and will develop this tree such that all those extensions are generated. Now let us try to see how it actually happens. Now let us take an example. This example is a small one, because if I take a very big example, it will be difficult to explain you, because the tree will become very fat. Now suppose there are only 3 sequences, S1, S2, S3, which is a part of the database tree. And the sequence S1 is CAG, AAGT, and these are all a part of ACGT, which is nothing but the set of symbols sigma. And I want to find what are the frequent subsequences when the minimum support threshold is given to be equal to 3. Now what I am going to do, I want to find what is the minimum support if it is given that the particular thing is equal to, the minimum support is equal to 3. Now if I just try to find it by inspection, I find that A occurs in all the three sequences, G occurs in all the 3 sequences, T occurs in all the 3 sequences. Therefore, this AGT, which will be part of the frequent one. Now, if I generate this if I generate the other one, I will be able to find that AA, AG, GA, GG also occurs in all these sequences. Why? You see that A is here, or A is also here also. Then you find AA is here. Similarly, here A is here. Yeah. Similarly, AG, GA, and these 4 sequences are of size 2. If I come with 3 sequences, I find that AAG is in all the 3 sequences. You see, AAG. You can also take this one, this A, you can take this also. This A, and this G. This is not AAG. Similarly, I can take here AAG. And therefore, all these 3 sequences contains AAG. Similarly is the case with GAA and GAG. And if I take the frequent sequences of 4, I find that only one is there, and this is GAAG. And here, when I take this GAAG, you find that is a part of all the 3 sequences. And since I am taking the minimum support of 3, I will keep all those subsequences which are all frequent with a minimum support of equal to 3. But this method, what we are trying to do, is a manual method. Obviously, it cannot work for a large data set, and therefore we can apply some other algorithm by which we can try to find from a big sequence, a big database, and having a sequence of size big size. Now let us try to apply the algorithm of generalized sequential pattern. This algorithm is called a GSP algorithm, and the GSP algorithm is going to search the sequence prefix tree using a level wise, or we can say apply the BFS, the breadth first search. Okay. Now, how this algorithm will work? We will first of all we have to give some minimum support. Now then we generate all possible sequences at level k plus 1, and then we calculate the support of each candidate and remove all those which are not frequent. And therefore, that means we make at k plus 1, then we are going to do it for k plus 2, then we are going to do it at k plus 3, keep on doing until we cannot generate any more frequent sequences. Okay. Now, the terminology, when I am going to generate the prefix search tree at level k, we will call it this by this C of k, where C of k is like k is equal to 1. Therefore, initially C of k is equal to C of 1. That means it comprises all the symbols at the root level, because it contains all the symbols. In this case, it could be ACGT. Okay. Then after that we generate C of 2, which will be containing sequential of length 2. Now let's take an example in order to do it now this is how we are going to do it. The example will make it very clear how we are going to do this. Okay, now let us try to see this one. I start with a null. Now here, this one is a null. That means this is a null. And therefore, this what we are going to do over here is a null. Okay, we start with null. Then we write all the symbols A, C, G and T, and count the occurrence of A, C, G, T in the database G. Now suppose A comes 3 times, C comes 2 times, G comes 3 times and T comes 3 times. Now at this step I will try to check what is the minimum support I got. What I have taken. Now suppose I have taken the minimum support is equal to say 3. Therefore, in this case, this one is not required and you will remove this, because C is having a support of equal to 2, which is less than minimum support, and I will not take it. Now after that, this is C1, because I am generating, so I am going to generate C1. Okay. Now with this one, I am going to prune it. I am going to prune it. Now this is pruned. Okay. Now I take the other one. I am going to take this one and find extensions of A. Now what are the extensions of A? Obviously it will be a double A, AC, AG and AT. But I will not take AC because C is already pruned or C is already removed. Therefore, the extensions of A are double A, AG and AT. And then I am going to check the database to find that whether it is frequent or not. And if I check the database, I find that double A comes 3 times, AG comes 3 times, and AT comes 2 times. Similarly, I generate the other sequences of G. Now for this G, I generate GA, GG, and GT. Therefore, I generate three extensions of G, GA, GG and GT. Then I generate extensions of T, TA, TG and TT. That means from 3 I generate 9 extensions. 3 for A, 3 from G and 3 for T. And from the database I check whether AA comes or not, whether AG comes or not. And therefore if I go to here, I can find that AA comes. If I am going to see over here, in how many times C is coming? Only 2 times in S1 and S2. Therefore, C was removed. Now, if I check over here, let us check for AA and AT. AA occurs in S1 also, S2 also, and S3 also. Now, let us take AT. AT occurs in this one. It occurs here. It occurs here. It occurs here. Not here. Sorry. It occurs here. Okay, it occurs AT over here. In here also A and T occurs over here. It occurs here. It occurs over here. It occurs here. It occurs here. But in S2, AT is not there. Because I am trying to find AT. TA is there, but I cannot take TA. Because TA is there, but TA is not required because TA and AT are different when I am going to take the sequencer. These two are different. And therefore, I cannot take TA. Okay. Therefore, AT, that the support for AT is equal to 2 only. And therefore, that will not pass the minimum support because the min support I have taken over here is 3. I have taken equal to 3 over here. Correct? Now, so that means I can remove AT. Similarly, I will remove GT, TA, TG, TT because either they are less than minimum support or they are not present at all. For example, TT is not present anywhere. Now this one. This one is not present anywhere. Now you just check. There is no TT. Either in S1 or in S2 or in S3, there is no TT. Therefore, what I am going to do, I remove all those. The shaded ones, the grey shaded ones are removed. Now I am going to generate extensions of AA. What are extensions of AA? Obviously, AA with A, AAA, AA with G, AAG, and AA with T, but it will not be there because no extensions of T are frequent. Okay. Therefore, you do not require to generate AA with T. Okay. Now, let us try to generate for A. It is AG and AT. Now, here, similarly, I will do it for AG with A. Therefore, I am going to find all those extensions of there. And again, check the database to check whether AAA is frequent or not, AAG is frequent or not. And when I am going to find this, I find that AAA does not pass the minimum support, whereas AAG passes the frequent support. Okay. Therefore, after running the algorithm at say at this part is called the C1 part. This part is called the C1. This is C2. This C3. This C3. This C4. All those ones which are white boxes. These are all which passes the frequent patterns. Whereas all those gray ones are removed because they are infrequent sequences. And at the end of the algorithm, I find that the only frequent sequences are AGT, AA, AG, GA, GG, AAG, GAA, GAG, and GAAG. And therefore, these are the frequent sequences over the database T. Okay? Now, this is how the algorithm works. The algorithm is too simple, except that you have to understand that at each time when I am generating the other candidates, I have to scan the database. How many times I scan the database? Anybody? How many times did I scan the database?
So जितने levels होंगे
Number
उसकी
of
बात.
nodes.
That means 4 times. At C1, at C1, then at here C2, at C3 and C4. That means the number of the biggest sequence which I generated was 4. Therefore, in that case, I generate 4 times. Because,
Sir,
yeah.
I have one question, sir. How we will keep that track? Like in this, like in third level, we are generating AG, but we didn't generate AAT. So it's T
It
is
did not generate
grade.
AAT.
Yes, sir.
See,
So
actually, this is a prefix tree, but actually you will be doing a database. Now, if I remove this AAT from the database, extensions of AAT will not be generated. Why? Because you are applying a join. Now, how I am generating AAA? Because you are joining AA with A, AA with G, and AA with T. Okay. Now, since this T, suppose if I take this T. Now, suppose this T is not there. Is not there in a database itself and it's removed. Now, when you join AA with A, it's there. Then, if AT is not there, you will not be joining. You are not generating any further extensions of AT because you are cloning from the database. Suppose in a database, initially you are maintaining all those candidate keys. But removing all those candidate keys, once you find that it is infrequent, you remove from the database. And then you join one with all. You join one with second, one with third, one with fourth, one with fifth. If these ones which are shaded, gray shaded, are removed, they will not be generated. Therefore, this is an example. But actually, you have to maintain a database in order to do this. This is an exhaustive this search tree where you are going to do. The algorithm will discuss also. Just an example how you are going to do. Now just see this algorithm. This algorithm is the one which you have done, just what we have spoken, this we are just going to do. Now here, the GSP will work with 3 parameters. P, which is the database, sigma, which is the list of symbols, and minimum support, which is a user given. Okay. Now these 3 are the parameters of GSP. Okay. Now I start with f is equal to 5, null. And initially C1 is equal to null. That means it contains one single symbol which is null. Now for each S which is an element of sigma, we add S as child of sigma in C1 which support S. Now here, if you check over here, one thing you should know that I have maintained a sigma over here. I have maintained this as a phi, which is null. But I have at least one symbol at the null level. Okay, and this will be common to all. Therefore, I put the count as equal to 3. Now here I add S as a child of phi in S1, where the support initially is 0. Now I am going to calculate the support. While C of k is not equal to phi, I calculate the support of C of k comma D. For each leaf S, which is an element of C of k, if support of R is equal to mean support, then I do F is equal to F union of R comma support of R. Now you remember F initially was phi, and I am writing F union of say A. Therefore, I get F is equal to A. Now next time F is equal to A, I write A of union of say A. A union of A will give you double A. And if the support of R is not equal to mean support, I remove S from CK. Now this is what you have been asking, that if it is not there, what I will be doing? I will remove S from CK. Now here initially K is equal to 1, because I start with K is equal to 1 here. I start with K is equal to 1. And this K initially will be equal to 1. Okay, I get C of k, that is C of 1. Then I extend C of k with C of k plus 1. Now I extend the value of Ck plus Ck is equal to C of k plus 1. Now I am going to extend it to C of k plus 1. How I am going to do? C of k plus 1 will be generated from Ck. And then this while loop will work with C of 2. And a time will come when you are going to extend, it will not be extended because there are no more items. And then you are going to return f of k. Now f of k. Now here, when I am going to return this f of k, it is going to return all this, because k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4. Therefore, it is going to return all fk. Fk means with f, therefore the frequent item with 1, 2, 3, 4 till k is going to update with k is equal to k plus 1. Therefore, you find that D is the database, which I am going to check with the support here. Minimum support, obviously I am going to compare over here. If it is equal to, then only I will do. Otherwise, I will not be doing. If I will not be doing. Okay, and this is the symbol that it is also possible that some of the symbols might be there which is not a part of that sigma, because in this case I am only doing for ACGT. Now maybe there could be a symbol called P, or maybe symbol called R or Z. Now that will not be a part of sigma. Therefore, this one condition is going to check whether that particular thing is a part of sigma or not. Otherwise, there could be some sequence which might be, for example, there might be some sequence like GAAGTZ or GAZAPGT. Now there might be some symbol, some extra symbol over here, and therefore that will not be a part of sigma. Therefore, I have to also check whether the symbol which I am going to find, whether it is a part of that initial list of symbols. If it is not there, I will not take. Okay. Now by this method, I will be able to return all those frequent sequence patterns. Now here, it can also, it could be a subsequence, it could be a substrings, it could be a prefix, or it could be a suffix. Now, in text, you might have heard about that the sub-str. Now, in sub-str, you might have done in the second year when you are writing program to find the sub-str. You know the functions in C. You have a sub-str function. Now, that sub-str function checks for consecutive strings. But here, when I am going to do a sequence mining, it is not going to take consecutive. It could be consecutive, it could not be consecutive. But here, if I take a sequence, say A, comma C, ACT, A must occur before C. Therefore, the position of A should always be less than the position of C. And the position of C should always be less than the position of D. It is possible A is at 4th position, C is at 9th position, and T at 12th position. And therefore, the sequence mining is applied to places where you are very sure that the sequences occurred at this time intervals. Okay? The time interval I am not taking, but of course it means that it occurs before that. There are a lot of applications of sequential patterns. One of the very important applications is in the case of medical diagnosis, or in your buying patterns, where you are buying some other items, and after buying that item, you are going to buy the next item, which happens normally when you buy a computer, you buy a printer, you might buy some other accessories which are related to you buy antivirus software, and so on. But therefore, if I know that you have bought a computer, I can promote some scheme to you so that you can buy a printer, or maybe some software related to you. Or you buy a mobile, then you buy several accessories of mobile. You buy a headphone, or you buy some particular Bluetooth device after you buy a mobile phone. Okay. Therefore, this is actually how it works. Therefore, whenever you have, therefore you can apply it to many different fields. For example, I can try to find your patterns of usage pattern of your ATM card. If I know that, say, in the initial month of you withdraw, say 2,000 rupees, after that you withdraw 500 rupees, or maybe there is some patterns over there. Now, in the initial 7 days, you might withdraw 10,000. In the next, you might be withdrawing, say, some lesser amount, and this is a pattern. Now, suppose at the end of the month, you might have withdrawn a large amount. That means that there might be some different type of payment which is not like which you have been doing initially. And this is actually where there are a lot of places where you can put. But all these sequence patterns are basically frequent patterns. Therefore, sequence patterns are a subset of frequent patterns. Sequence mining is a subset of frequent pattern mining because we are trying to find a frequent pattern. Okay. Now we stop at this point, and anything you want to ask, please.